Hello, this is Mr. McGough. I'm going to be doing the Unit 3, Day 1, Introduction to Matrices. You please note that in the notes packet there is a review. However, I tried this video already and it took me 9 minutes to do that review. So I'm just going to go ahead and start right into the notes and leave that review for you and your teacher, or I'll go ahead and do a separate video for that. So first off, matrices. A matrix is a collection of numbers that are arranged into rows and columns. Rows go across and columns go down. The dimensions of a matrix given in the form rows times columns. So for example, there are 2 rows and there are 3 columns in our example. So our example is a 2 by 3 matrix. Scalar multiplication is the multiplication of each element in a matrix by a single real number, called a scalar. Think about it like you're scaling up or scaling down. If I multiply it times 2, I can multiply it times 1/2. I can multiply it by the square root of 2. All of those are real numbers. Anything greater than 1 will scale it up. Anything less than 1 will scale it down. To add or subtract matrices, they must have the same dimensions. When they do that, you will add or subtract corresponding entries in the matrices. So think about a simple matrix like 1, 2. We're going to add to that another matrix, 3, 4. So when we do that, 1 plus 3 is 4. 2 plus 4 is 6. So corresponding entries are added together. When you think about a scalar, what does it mean to multiply something times 2? It would mean the same as adding them together, adding it to itself. So no difference between adding it to itself or just doing 2 times the matrix 1 over 2, which would also give us 2 over 4. So here we have some examples. On question 1, we want 3 times A. So you'll do 3 times each of those elements. When we do that, 3 times 4 is 12. 3 times 5 is 15. 3 times negative 3 is negative 9. 3 times 0 is 0. 3 times negative 7 is negative 21. 3 times 10 is 30. Number 2, I'm going to take negative 2. I'm going to multiply it times B. Each element, rows and columns. Negative 2 times negative 3 is positive 6. Negative 2 times 0 is 0. Negative 2 times 4 is negative 8. Negative 2 times negative 1 is positive 2. We're going to add or subtract matrices. Matrix A, matrix E. So corresponding elements. 4 plus 1 is 5. 5 plus 2 is 7. Negative 3 plus 6 is positive 3. 0 plus negative 4 is negative 4. Negative 7 plus 6 is negative 1. 10 plus 8 is 18. On number 4, first I'm going to do 3 times B, and then I'm going to add C. So let's take a look. B is 2 by 2. C is 2 by 3. Well, in our notes, we just said they have to have the same dimension to add them together. So while I can compute 3 times b, I can't add it to c. So we can't do this one. Number 5, 2 times b, which is 2 by 2, minus 3 times d, which is also 2 by 2. We can do that. Remember, subtraction is just adding the negative. So first, we'll do 2 times b. 2 times negative 3 is negative 6. 2 times 0 is 0. 2 times 4 is 8. 2 times negative 1 is negative 2. Now we'll do negative 3d. So remember, instead of subtracting, we're going to add the negative. So negative 3 times negative 3 is positive 9. Negative 3 times 4 is negative 12. Negative 3 times 2 is negative 6. Negative 3 times negative 1 is positive 3. So think about this kind of like if we were distributing into a multinomial. So now we're going to do the addition. We're going to add each corresponding element. Negative 6 plus positive 9 is positive 3. 0 plus negative 12 is negative 12. 8 plus negative 6 is 2. Negative 2 plus 3 is 1. So here's our solution. Now, how do we use these? Well, first let's represent a point, x comma y, as a matrix. So my point, xy, would be x1, y1. So if, for example, I wanted to represent the point 1, 2, I would rewrite that as the matrix 1, 2. And here's my point 1, 2. If I wanted to represent a line segment with endpoints x1, y1, and x2, y2, well, I'd have x1, y1, x2, y2. So let's say I'm going to have this line segment from the point 1, 2 to the point 3, negative 1. I would have 1, 2, 3, negative 1. To translate the line segment, I'm going to use matrix addition or subtraction. Which really I could have just set matrix addition because subtraction is just adding the negative. If I want to dilate, stretch, or shrink a line segment, I will use matrix multiplication. Scalar multiplication. So let's see how that works. So first, I have a line segment with endpoints 4, negative 3, and 1, 2. So I'm going to translate this segment right 4 and down 6. Right is my x. 4 is positive. So I need to add 4 to every x value. I'm going to go down 6 units. Well, down is y. Up and down are y. And down is minus. And I need to do that for each y value to take this line segment right 4, down 6. Plus 4 for x, minus 6 for y, for each x, for each y. So when I add these together, I'm going to add corresponding elements. 4 plus 4 is 8. 1 plus 4 is 5. Negative 3 plus negative 6 is negative 9. Positive 2 plus negative 6 is negative 4. So here would be my new line segment with the points 8, negative 9 and 5, negative 4. Let's think about that from one of these points. If I took the point 4, negative 3 and I moved it right 4, that would be 8, negative 3. If I then moved it down 6, it'd be 8, negative 9. So it makes sense. Let's dilate this line segment, the original line segment, by a factor of 1/2. So I'm going to multiply it by a scalar 1/2. When I do that, 1/2 times 4 is 2. 1/2 times 1 is 1/2. 1/2 times negative 3 is negative 3/2. 1/2 times 2 is 1. If we think about this being plotted, 4, 1, negative 3, 2, and now it shrinks. So we took our original line segment and we dilated it. So you may remember that from geometry when we do these transformations, when we shrink or compress or expand. You get this projection out from the origin. Next, line segment has endpoints, negative 2, 7, negative 2, negative 7, and 3, 5. We're going to translate the segment up 4, left 8. Left and right are x, so x is on top. Left is negative, so it would be minus 8 on top. Translating the segment up 4 units, so y will be plus 4. So to my x values, negative 2 plus negative 8 is negative 10. Positive 3 plus negative 8 is negative 5. For my y values, negative 7 plus 4 is negative 3. 5 plus 4 is 9. If we want to check, from negative 2, negative 7, if we move left 8 units from negative 2, we move to negative 10 in the x. From negative 7, we move up to negative 3 in the y. We're going to dilate this line segment by a scale factor of 2. Negative 2, negative 7, and 3, 5. We're going to multiply this times 2, our scalar. When I do that, 2 times negative 2 is negative 4, 2 times 3 is 6. 2 times negative 7 is negative 14, 2 times 5 is 10. For our next problem, we're told our line segment with our 2 endpoints. We're asked how the translation is working. Well, on the top of our translation is what we do for x. That's left 3. And on the bottom is what we do to y. That's down 2. I'm going to go left 3, down 2. The last part of the notes. 2 matrices are equal if all of their corresponding elements are also equal. So they all have to be equal. If we do that, we can solve for our variables. For example, 2x would have to equal 4. 5y would have to equal 5. And 4z would have to equal 8. So x equals 2, y equals 1, z equals 2. Is that true for the others? Well, x is 2, y is 1, 1 plus 4 is 5, 3 times 2 is 6, 2 plus 7 is 9, 14 times 1 is 14, 9 times 2 is 18. Go ahead and try that homework and have a good day. If you need any additional assistance, talk to your teacher or I am up in R12.